Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/helpisu actuary. Here's a problem for today for exam LTAM, long-term actuarial models. You are given the following information on participants entering a special 2-year program for treatment of a disease. Only 10% survive to the end of the second year. The force of mortality is constant within each year. The force of mortality for year 2 is 3 times the force of mortality for year 1. Calculate the probability that a participant who survives to the end of month 3 dies by the end of month 21. Let us write mu for the force of mortality in the first year. Then the force of mortality in the second year is 3 times mu. The probability of survival over 2 years is e to the minus mu times e to the minus 3 mu, which is e to the minus 4 mu. And we know this to be 0.1, so that mu is equal to negative 0.25 of the natural logarithm times the natural logarithm 0.1. Which is, the natural logarithm of 0.1 is minus the natural logarithm of 10, because 0.1 is 1/10. So this is the same as 0.25 times the natural logarithm of 10. The two minuses cancel. And then this is the same as natural logarithm of 10 to the power 0.25. The probability we are looking for, time counted in years in this, is 1.5 q 0.25. So a person who has been in the program for 0.25 years, what's the chance that this person leaves the program within the next 1.5 years? It's equal to 1 minus 1.5 p 0.25, which is 1 minus 0.75 p 0.25 times 0.75 p1, and we separate the first and second year because the forces of mortality are different in those 2 years. But then we know the force is constant in each year, so that the first probability is e to the minus 0.75 mu, because the force of mortality in the first year is mu, and the second probability is e to the minus 0.75 times 3 mu, because the force of mortality in the second year is 3 mu. Well, that's equal to 1 minus e to the minus 3 mu. Mu is equal to ln of 10 to 0.25, so this becomes 1 minus e to the minus 3 times ln of 10 to the power 0.25. That's equal to 1 minus, and then we can take e to the power, we can take this negative 3 actually to the power of 10 in the expression in the exponent. So the exponent would become ln of 10 to the power minus 3 times 0.25. And then we can write this as 1 minus e to the ln of 10 to the power minus 3 times 0.25. So this is 1 minus 10 to the negative 0.75. That's approximately 0.822172006, and that's answer E. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.